The next big leap in drone tech isn't about making them faster or smaller. It's about keeping them in the sky almost indefinitely. Imagine a world where drones don't have to land to recharge, especially when landing is dangerous, impossible, or just wildly inconvenient. If engineers can truly figure this out, we're talking about UAVs that stay on mission without interruption. Right now, there are two major paths researchers are exploring to make that happen. One of them involves beaming power through electromagnetic waves over long distances. Back in 2021, DARPA funded research into this idea, awarding $750,000 to Dr. Afana Mahboub at the University of Texas to develop a way to precisely direct electromagnetic waves at drones mid-air for line-of-sight charging. Yes, charging a drone while it's flying. Dr. Mahboub later founded Kinetics Beam to push that idea further. The company is developing long-range wireless power systems that use advanced phased arrays, reconfigurable metasurface lenses, and conformal rectennas to capture that energy. It sounds complex, but the goal is simple: send power through the air accurately and efficiently enough that a drone can just keep flying. DARPA has also been experimenting with laser-based systems. In New Mexico, it tested its persistent optical wireless energy relay, or power system, and managed to deliver 800 watts of power via laser over 5.3 miles. That's a serious distance. The receiver used in that test was developed by PowerLight Technologies, along with a specialized transmitter. The test broke previous optical power transfer records, although it was done with ground-based equipment rather than actual airborne drones. Meanwhile, one company is already further down the runway with this concept. PowerLight Technologies, based in Kent, Washington, has been working on laser-based power transmission for over 2 decades. Last December, the company announced it had successfully tested a system capable of delivering kilowatt-level power to a drone flying at 5,000 feet. And according to them, their non-visible laser beam can transmit power over kilometers. To make that possible, PowerLight built a portable, though still fairly large, transmitter system that can track and lock onto a drone in flight. It also includes built-in safety systems for the beam, plus real-time control and monitoring. So in theory, you could tow this transmitter to an ideal location and continuously recharge a drone as it flies overhead. For testing, PowerLight mounted a lightweight 6-pound receiver onto a K-1000 ULE drone made by Kraus Hamdani Aerospace. That particular drone is already used by the US Navy and Army, so it's no toy. The transmitter converts stored battery power into high-intensity light, shapes it into a non-visible laser beam, and sends it through the air. The drone's onboard receiver then uses photovoltaic cells to convert that light back into electrical power. It's basically solar power, but delivered on demand from the ground. PowerLight says its transmitter and receiver systems are now entering their final validation stages, with fully integrated flight trials planned using the K-1000 ULE. If everything goes according to plan, we could soon see drones that stay airborne for incredibly long stretches of time. And think about what that means. Defense support, reconnaissance, search and rescue, oil and gas pipeline monitoring, all without being limited by battery life. In cities, drones could monitor traffic, track air pollution, and support emergency services for far longer than they can today. We're essentially looking at the possibility of refuel-free drones. No pit stops, no risky landings, just continuous flight powered by invisible beams from the ground. If this tech matures the way engineers hope, the sky might start looking a whole lot busier,